Hello friends, today I will discuss the stepper motor, the necessity of it, construction, principle and operation, and its applications. The necessity in the robotics is its open loop system used to provide the precise positioning and speed control without requiring a feedback sensor. It is also cheaper. When it comes to the construction, it will have the stator with electromagnets whose polarity changes with respect to time. Then magnetic field generation by the stator field, and a rotor with permanent magnets with fixed polarity, and rotor alignment, sequential energizing the coils of the stator, continuous rotation of the rotor. This outer part is called the stator. These are the A dash, B dash belongs to the stator windings. These windings are supplied by the AC supply in such a way that only one coil is excited at a time, or one phase is excited at a time. Look at this. This is the rotor whose poles are already fixed. This is north pole, this is south pole, this is north pole, this is south pole, this is north pole, and this is south pole. Means totally there are 6 poles in the rotor. And whereas stator has the totally 4 poles, and the phase A winding is excited first. That is A dash is connected to the supply. In that case, here north pole will form and here south pole is formed. Now this is the rotor south pole and this is the north pole. So the south pole attracted to the north pole. In the next moment, the phase A coils are de-energized, means supply is disconnected, but B coil or B phase coils are connected to the supply so that they form the new poles. So this becomes south pole and this becomes north pole. And this is the north pole and this is the south pole. So automatically this north pole of the rotor tries to align with the stator south pole. That is, it is moving in the clockwise direction. Next, again, the B winding is de-energized, means supply is disconnected, whereas A phase winding is connected to the supply so that it forms here south pole and this forms north pole. And here this is the north pole and south pole, so they attract each other. In the next moment, so this phase A's power is cut or de-energized, then phase B is connected to the supply so that this forms here a north pole and this is the south pole, and this south pole of the rotor tries to align with this north pole of the B phase. So that is a rotor rotates in the clockwise direction continuously as long as the stator changes its polarity in this way. The same thing can be explained here like this. This is the real diagram. And there are phase A, phase B, phase C coils on the stator, and this is the rotor with permanent magnets. Initially, look at this. Phase A coil is energized, means A and A dash are energized. So it forms the poles, and in such a way that the north pole of the rotor and south pole of the stator will attract each other In the next moment, this phase A coils are de-energized and coil B are energized, so that the pole of the rotor will continue to align with the newly energized coil. In the next step, coil B is de-energized, but whereas coil C is energized. Then the rotor poles tries to align with the new coil magnets or formed magnets or electromagnets. So like this, the stator magnetic poles continuously changes in such a way that the rotor will move continuously. This is the real diagram that you can see here. Stepper motor. This is bearing, shaft, front end cap, winding, frame, insulation, leads, rotor 1, permanent magnet, and rotor 2, winding, rear end cap, stator, like this. So there are other ways of drawing the same diagram like this. So we have this stator like this, and it have the A dash coil and B dash, and where the rotor has the permanent magnets, that is, this is north pole and this is south pole, this is permanent magnet. Similarly, same stepper motor can also be shown like this. This is the rotor with poles, permanent with poles, whereas this is the stator winding and this is the stator. If the stator is connected to the supply and its energization changes with respect to time, then automatically rotor will follow the stator magnets. When it comes to the applications, it is ideal for the applications like 3D printers, robotics, automated machinery. Let me summarize once. Stepper motor consists of the two parts. One is called the stator with electromagnets whose polarity changes with respect to time, whereas the rotor have the permanent magnets with permanent polarity like this. As the stator changes its poles with respect to time, the rotor poles will align with the stator so that the rotor will continue to rotate along with the stator magnetic field. For getting the continuous change of magnets on the stator, only one coil should be switched on first, and next another coil should be switched on, but whereas the previous one should be de-energized. Next, the second coil should be de-energized, and then third coil will be energized, so that the poles will change and the rotor will follow the stator poles and make its rotation continuous. And its applications are like 3D printers, robotics, automated machinery, etc.